Okay guys, so this is the video for 12.4 and this is our final section that we're going to cover on matrices. And in this section we're going to talk about the inverse matrix. Okay, so to define it, okay, an n by n inverse matrix is a matrix that consists of ones on its main diagonal and all other elements are zero. Okay, so there's a couple things here. First of all, it has to be an n by n. So a 2 by 2, a 3 by 3, a 4 by 4, it has to have the same number of rows and columns. Okay. And the second part is it only has two numbers. Okay. It's going to have 1 on its diagonal. So, oh, so in 2 by 2, this is its diagonal. A 3 by 3, this is its diagonal. Okay. 4 by 4, you'd have 4 across the diagonal. And the reason it's such a thing, or that we need it, is right here. Okay, so if A is any n by n matrix and L is the n by n, or I is the n by n identity matrix, all right, guys, so this is the video for 12.4, and in 12.4, we're going to talk about the inverse matrix. Okay, so to define it, okay, so the n by n inverse matrix is a matrix that consists of ones on its main diagonal and zeros for all other elements. So there's a couple things here. First of all, it's an n by n. So the number of rows has to be the same as the number of columns. So it's going to be a square matrix. Okay. And then the second part is this here. It's only consists of ones and zeros. So there's going to be ones on its main diagonal, and then it's going to be 0 in every other place. So if I look at a 2 by 2 identity matrix, our ones here, and then everything else is zeros. Okay, a 3 by 3, we have ones along its main diagonal and zeros everywhere else. So this will be the same for a 4 by 4, 5 by 5, so on and so forth. Okay, now the cool thing about an inverse matrix, or what it helps us with, is right here. Okay, because we can multiply the inverse matrix by any other matrix and it won't change the matrix. Okay, so it's like multiplying something by 1, if you will. So it says two n by n matrices, A and B, are inverses of each other when their products of n by n is the identity matrix. Identity. Okay, so if we multiply a matrix by its inverse matrix, we'll get an identity matrix. If we multiply a matrix by the identity matrix, it won't change. Okay, so we'll do some examples that'll make more sense. All right, guys, so as promised, we're not going to go into a whole lot of depth this chapter, just kind of brush the surface. So we're just going to apply 2 by 2 matrices right here to find the inverse matrix. Okay, so we have a method that we can find the inverse matrix. Okay, so if we take any matrix, we'll call it A, B, C, D. Okay, we can find its inverse matrix, and just like any inverse function, it looks like a to the negative 1. That's just a's inverse, not to the negative 1 power. Okay, by first multiplying it by 1 over its determinant, so we're going to have to find its determinant. Okay, and then multiplying it by the same but different matrix. So notice in this matrix, our A and D, we flipped their spots. Okay, our B and C, they kept the same spots, but they flipped signs. So if B is positive, it's now going to be a negative. If C is a positive, it's now going to be a negative. Okay, and we can only do this when our determinant is not equal to 0, which makes perfect sense because if it equals to 0, this here is going to be undefined. All right, so let's find the inverse matrix of A. Okay, so the inverse matrix is going to be 1 over its determinant times my D and my A flip spots, so D, A, and then my negative B and negative C go here. Okay, I got that straight from this right here. All right, so this is going to equal 1 over, remember my determinant can be found by 4 times 5 minus 7 times 3. Okay, now I can flip the places of A and D. So my A is going to be where my D is going to be where my A is. So I have a 5 here and a 4 down here. And then my B and my C are going to flip signs. Well, they're both positive, so they'll now become negative. So -7 and -3. All right, so let's simplify this down. So this is 1 over, well, 20 minus 21 is a -1. 5 minus 7 minus 3 and 4. Well, guys, 1 over -1 is just a -1. 5, -7, -3, and 4. And so when I apply the scalar, when I multiply it through, I have -1 times 5, which is -5, and -1 times a -7, which is a +7. I have a -3 times -1, which is a +3, and a 4 times -1, which is a -4. Okay, so this would be my inverse matrix of this. Okay, so now because this is the inverse matrix, okay, remember that if we were to go back to our original matrix, so 4, 7, 3, 5, okay, and we would multiply it by our inverse matrix, what we would get is the identity matrix. Okay, if you don't believe me, go ahead and work it out, but I'm not going to waste the time on the video. All right, so I want you to go ahead, try B on your own. So I want you to pause this video, look to A as your reference, and go ahead and do B on your own. And then when you're done, unpause it and we'll go over the answer. All right, so hopefully you worked through this one on your own. Okay, so 1 over the determinant times and then the flipped around matrix. So the determinant can be found by multiplying the diagonals. So 5 times 2 minus 3 times 4, okay, which is 1 over 10 minus 12, which is 1 over -1/2. Okay, and then when we flip these around, we flip the places of this diagonal, so this becomes our 2, this becomes our 5, and then we make both of these the opposite sign, so -3 and -4. And then when we multiply the scalar of -1/2 through, we would get this here. Okay, and remember, if we multiply this matrix by our original matrix, we would get the identity matrix. All right, so let's look at matrix C now. Okay, so let's go ahead and find the identity matrix for matrix C. Or sorry, the inverse matrix for matrix C. So it'll be 1 over the determinant, so 1 over -6 times -3 minus, and then 9 times 2. Okay, and then I'm going to multiply that by, okay, well, I'm going to flip the places of these two, so -3 and -6, and then I'm going to make these the opposite signs, so -9 and -2. Okay, so if I clean this up, this is going to be 1 over 18 minus 18 times -13, or -3, sorry, -2, -9, and -6. Okay, which is simply 1 over 18 minus 18 is 0. Okay, so I can stop here. This tells me that this matrix here does not have an inverse. Get rid of that. Does not have an inverse. So we can't find the inverse then. Okay, and we can simply stop right there at that.